Today we'll review our exponent rules. Take a look at our vocabulary. All of these rules only apply when we have the same base. So remember, the base is that bottom number. Starting with the product rule. The product rule simply means when we're multiplying exponents with the same base, we look and we see our base is the same. This means we have 2x's. This means we have 3x's, and we can clearly see that we would add those x's together. So the product rule means you add your exponents together. So something like this problem, 2 to the 5th times 2 to the 6th. Instead of having to write it all out, it would become 2 to the 11th. You simply add your 5 and your 6. That is the product rule. You need to have that memorized. The power of a power. So now you have something in parentheses raised up to a power. So you have x to the second raised to the third power. So what this means is x to the second is multiplied by itself 3 times. So you have x to the 6th. So this would also be something like 2 to the 3rd to the 4th. So now you really have 2 to the 3rd times 2 to the 3rd times 2 to the 3rd times 2 to the 3rd. Now you're going back to that product rule where you really have 2 to the 12th power. You also need to have this memorized. This is where it gets a little tricky. This is the power of a product. So listen carefully as I show this. So now you have 2x to the 3rd. 2x to the 3rd. So this is really 2x times 2x times 2x. So you can use your commutative property by switching things up and say this is like 2 times 2 times 2 times x times x times x. And I suggest doing that because it helps you see that 2 times 2 times 2 is in fact 8. And x times x times x is in fact x cubed. So that really gives you 8x cubed, not 2x cubed. You have to share that cubed with both items. So this is probably the trickiest rule. The quotient rule. Quotient, remember, means division. And you are simply subtracting your exponents instead of adding them. It's illustrated here. X to the 5 is 5x's. X to the 3rd is 3x's. You can see that they cancel out. But saving us that writing step, we can see that that turns into 2, which is what you get when you subtract those exponents. So you could see a quotient rule like 6 to the 7th divided by 6 to the 3rd. And you would know that that would be, instead of listing it out, 6 to the 4th by subtracting your exponents. Now we did also learn about negative exponents, and our negative exponents come in when you have something to the negative power, so x to the negative a. So for example, if you have x to the negative 8, that is the same as 1 over x to the 8. It's positive version. If you have 1 over something that's negative, that means you flip it and you put the x in its positive version. So this is something you really want to take time to memorize, and then you'll get a chance to apply it. So you might see this come up in a quotient rule, for example. Perhaps you see something like x to the 7th over x to the 9th. When you subtract, 7 minus 9 gives you negative 2. So now you have x to the negative 2, which is the same as 1 over x squared. So you want to know negative exponents so that when you see it in a quotient rule or a product rule, you can apply that. We also learned about 0 exponents. Anything raised to the 0 power is 1. Memorize that for sure. Now, why does it work? We learned a more complicated version of why this works, but a simple version is anything divided by itself ends up being 1. So x to the 3rd over x to the 3rd, when you do your quotient rule, 3 minus 3 gives you 0, so x to the 0. but we know anything divided by itself is 1. So x to the 0 and 1 would be equivalent. Now let's review scientific notation. And scientific notation has been created for a way to make writing big and tiny numbers easier. So something very large or something very tiny, the solution, scientific notation. Scientific notation is a quick and easy way of writing something. There's something you must remember, and that is that first coefficient needs to be between 1 and 10. So this number right here must be between 1 and 10. Sometimes you'll come up with an answer like 47.5, and you would have to say, well, I need to move this one more space over and then adjust the exponent. So parts of scientific notation, remember this is our coefficient, that first number. The base of our exponent is the 10, and then our exponent is our power. From scientific notation to standard form, if the exponent is positive, what you're going to notice is that you have a large number. If the exponent is negative, you have a tiny number. So how do we do this? You would say that you would take your decimal place. You see that this is a power of 6, so you move your decimal 6 places to the right. If the exponent is negative, you'll take your exponent and you'll say, I'm going to move it to the left. So you're moving it and making it big if it's positive, you're making it tiny if it's negative. Scientific notation is useful for answering questions like this. So these numbers are going to be very large or very small. If you feel you'd like practice, this is a good time to pause the video and say, can I answer these questions? Can I write this in standard form? Remember, standard form is simply the normal number, that very big or very little number. Please, if you want to practice this, pause the video. The next page gives the solutions. So now, I'm assuming if you're looking at this, you've chosen to try this, you've paused the video, and you'll notice the solutions are here. You can check your work. Moving on. Sometimes you can order numbers in scientific notation, and it is helpful to see some quick shortcuts for this. So if you see 3 different numbers and it says to place them in order, you would want to look at your exponents first. And if you see to the 4th power, you know that those numbers are bigger than something that's to the 2nd power. So we immediately know this is the smallest number. And then we'll look at those coefficients for the others. So these are both raised to the same power, but 2 is smaller than 3.2. So that would be smaller. If they are all the same, then you wouldn't have to compare your exponents. You would just compare your coefficients. You can see your coefficients are what's left here to compare. So placing them in order. Remember, our math signs for this number is less than the middle one, which is less than the large one. Now, when would you use this? You could see this in outer space when you're talking about a very large number. You can talk about light years this way, and you can see that you would compare those. You can say, turn this first number into scientific notation to compare it against the second number. So in summary, scientific notation is a short way of writing large or small numbers. Please note that this review does not cover multiplication of scientific notation or division. There are reviews in your Delta Math for that if you need that additional practice.